This is homework set 22, solving radical equations. Question 7, we'll start this one like we've always started these. We'll square both sides, right? Because we already have a radical isolated. So square both sides, we'll get the quantity. Square root of a plus 6 squared equals quantity a minus 6 squared. On the left side, when we square root, the radical's gone. We get a plus 6. And on the right side, we're squaring a binomial, so we have a template for this, right? Square the first, a squared. Multiply these two together, and then double it. Multiply them together, I get negative 6a. Double it, minus 12a, and then square the last, plus 36. Now, I got a quadratic. I'm going to get everything on one side, 0 on the other. I think I'll get everything on the right side, because I already got the square on the right side. So what I'm going to do is I'm going to subtract the a, subtract the 6. So I'll get 0 over here equals a squared, and then negative 12a minus 13a, and then 36 minus 6 is plus 30. Let's factor. So we will get a and a. Now I'm thinking, 30 and 1, I can't get a 13. 6 and 5, I can't get a 13. But 10 and 3, that'll work. 10 and 3, and the 30 is positive, so they have the same sign. So minus 10, minus 3. So here's what I'm getting as potential solutions, 10 and 3. Okay, but we need to check. We need to check both of these. So I'll do that right here at the top. So let's check. First of all, if a is equal to 10, then, all right, put that 10 right back in here, and we'll do a bunch of it in our heads. So I'll get square root of 10 plus 6. Is that equal to 10 minus 6? Well, on the left side, what do we have? 16. Square root of 16 is 4, so I get 4. Right side, 10 minus 6 is 4. It checks. All right, so I can conclude now that a is equal to 10 is a good solution. All right. Now, what about if a is equal to 3? Then, all right, put that 3 back up here into the original. We will get square root of 3 plus 6. Is that equal to 3 minus 6? Well, on the left side, we get 3 plus 6 is 9. Square root of 9 is 3. 3 equals, now 3 minus 6 is negative 3. Those are not equal. So this one doesn't work. So our only solution here is 10. We thought we had 2, but really we have only 1. Question 8, let's solve this by squaring each side because that radical is already isolated. So let's square both sides. So we'll make it look like this. The quantity, square root y minus 4 squared equals quantity y minus 6 squared. On the left side, you square a square root. Radical comes off. We get y minus 4 equals. Now, talk your way through our pattern. Square the first. Multiply the two together. Negative 6y. Double it. Negative 12y. Square the last. Plus 36. Now, the y squared is already on the right side. So let's get everything on the right side. So let's subtract y, add 4. So we'll get 0 is equal to y squared. Now, negative 12y minus y minus 13y and 36 plus 4 is 40. Well, let's factor. 0 equals, all right, y and y. Now, 40 and 1 doesn't work. 20 and 2 doesn't work. 10 and 4 doesn't work, but 8 and 5 works. So 8 and 5, the 40 is positive, so they have the same sign, which is that middle minus sign. So I get 2 potential solutions here, 8 and 5. Let's check them both. So first up, if x equals 8, then, all right, now put that 8 back into this original, right there and right there. So that'll give us the square root of 8 minus 4. And I want to know, is that equal to 8 minus 6? Well, on the left side, 8 minus 4 is 4. Square root of 4 is 2. Equals 8 minus 6, that's 2. That one checks, all right? So we're good there with x equaling, or actually we got a y here, right? So y, all right, let's back that out. So y is equal to 8. That seems to be a good one. Now, if y is equal to, what was our other number, 5, then, okay, then we will get square root of, all right, now I'm going to put that 5 back in here and here. All right, so we will get the square root of 5 minus 4. Is that equal to 5 minus 6? Okay, well, square root of 5 minus 4 is 1. Square root of 1 is 1. 5 minus 6 is negative 1. Those aren't equal. All right, so this one doesn't work. Y equals 5 does not work. So we get only one solution here, and that is y equals 8. Now here in question 9, we've got the radical on the right side, but nothing changes. Let's go ahead and just square both sides. We'll get quantity x minus 3 squared equals the quantity square root 2x minus 6 squared. Using our pattern on the left side, we'll square the first, x squared, multiply the two together, negative 3x, but you double it, so negative 6x, and then square the last. Negative 3 times negative 3 is plus 9, and on the right side, square root, the radical comes off, 2x minus 6. Now, I've got the squared term on the left side this time, so let's just get everything on the left. So I will subtract 2x, add 6, so we'll get x squared. Now, negative 6x minus 2x minus 8x. And then 9 plus 6 is 15 equals 0. Don't forget to equal 0. I think this is going to factor. How about x and x? 15 and 1? No. 5 and 3 will work, though. 5 and 3. The 15 is positive, so they both have that middle minus sign. So we get two potential solutions here, 5 and 3. We need to check them. All right, so first up, suppose x is 5. Put that 5 back in here and here, so we'll get this. 5 minus 3, is that equal to the square root of 2 times 5 minus 6? On the left side, 5 minus 3 is 2. Is that equal to, now on the right side, 2 times 5, 10, minus 6 is 4, square root of 4 is 2, that checks. Okay, so that's a good one. All right, so that's a good one. So x equals 5 is going to work. Now, what about if x equals 3, then, all right, put that 3 in, we'll get 3 minus 3. Is that equal to the square root of 2 times 3 minus 6? This looks like it's going to work too, right? 0 on the left, and under the square root, 2 times 3 is 6. 6 minus 6 is 0. Square root of 0 is 0. That one works too, all right? So x equals 3 also works. So we get both these solutions. X is 5 and 3. Last question in this set. Here's what we know. From plane geometry and principles of similar triangles, the relationship between y1 and y2 and h is shown here. So here's, I got this relationship. 1 over h equals 1 over y1 plus 1 over y2. Where here's what we know. All right, I've got two poles. Right, here's a pole, like a telephone pole, and here's another pole. All right. Now, the two poles are 7 feet high and 5 feet high. All right, so like this pole is 7 feet high, this pole is 5 feet high. And then what you do is you take a cable and you attach it, like take a cable, attach it to this pole, and stretch it all the way down to the bottom of the other pole. Then you put a cable on top of this one and stretch it all the way down to the bottom of the first pole. Now, this is the height, right? Where those two wires meet, those two cables meet, that's going to be the height. So what you have is this, in any kind of a setup like this, where you have 1 over y1 plus 1 over y2, that's equal to 1 over h. And what we want to know is this. I'm going to draw this picture here in our particular situation. Okay, I got a pole here that's 7 feet high, a pole here that's 5 feet high. I'm going to run this cable down to the bottom here and run this cable down to the bottom here. What I want to know is, how high is it? We've got an equation here. The equation says this: 1 over h is equal to 1 over y1 plus 1 over y2. Now, 1 over h, don't know h, but I do know this. Say y1 is 7 and y2 is 5. Okay, now what's the LCD here? All right, what's the smallest number 7 and 5 go into, and h? Okay, well, 7 and 5 will both go into 35, so I can write 35h. So I know what to do here. I'm going to write that LCD, that 35h, in front of that term, and that term. And then all the denominators will cancel. So let's do it. So it's going to be 35h times 1 over h. That is equal to 35h times 1 over 7 plus 35h times 1 over 5. Right? All I did is I put that 35h right here, and right here. Now, all the denominators cancel, right? So h into h is gone, and then I get 35 times 1 is 35 equals. Now here, 7 will go into 35 5 times, so I'm left with 5h times 1. I'm left with 5h plus, and then over here, 5 will go into 35 7 times. 7h times 1, I'm left with 7h. I'll do it up here at the top right. 35 is equal to 12h. Divide 35 over 12 is equal to h. And that's it. So h is equal to 35 twelfths. But the question is, here's the question. What is the height above the ground? Now, the height is not h equals 35 over 12. The height is this: 35 over 12 feet. That finishes all of our questions on homework set 22.